right, so we're going to continue with scientific notation today. Today is Thursday, September 10th. And we are going to go on to continue with scientific notation. And we're going to try to change that back into standard notation. Okay, so there is your title. So again, we're still working with very large and very small numbers, except these numbers are already going to start in scientific notation. So we have to think backwards of what we did yesterday. And so I'm going to first do this. I know that yesterday my first step was to place the decimal. So in this case, my first step is going to be now to take off that decimal. I still am going to keep in mind where it was at, but I'm going to take off that decimal because I want to turn that scientific notation number back into standard. So now I want the big version of that number. So I also recall that the 6 told me place value, and it did not tell me zeros, okay? So we are not zeros, not looking at zeros. Okay, so 6 meant place value. So if my decimal was here, I am going to count 6 places to the right because it is a large number. 1, 2, 3, 4, 5, 6. And I'm going to place a new decimal there. So I'm going to go ahead and fill in those zeros. Again, we did not do 6 zeros. We did 1, 2, 3, 4, 5, 6 places. So 2.3 times 10 to the power of 6 is equal to 2,300,000. 2,300,000. All right, let's go ahead and try that again. Let's try 5.689 times 10 to the power of 7. All right, so I have to think backwards of what I did yesterday. First, I'm going to take off the decimal, 568. But I'm going to keep in mind where it was at because I'm still going to need to know where that decimal was. And now I'm going to look at 7 place value. So keeping in mind where my decimal was at, I'm going to count 1, 2, 3, 4, 5, 6, 7. And I'm going to put that decimal here at the end. That means that 5.689 times 10 to the power of 7 is equal to 56,800,000. I'm going to do that one more time, and then we're going to move on to the very small numbers. So again, thinking of undoing what I did yesterday, we got to think backwards. This becomes 5-1. And we're going to keep in mind where my decimal was so I can count 10 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice how I am not putting 10 zeros. I'm actually looking at place value. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is equal to 51 billion. So let's make a conclusion when my numbers are large and when my exponents are positive. We are going to count to the right. Because I want my number to get bigger. I want to see 2.3 become 2,300,000. I want to see 5.689 become 56,800,000. So I'm counting to the right. And I want to see 5.1 become 51 billion. In the same way, I'm going to look at my very small numbers that are in scientific notation. 1.760. Well, I don't need that zero. 1.76 times 10 to the negative 4. So again, I'm going to think backwards of what I did yesterday. 1.76. I'm going to write it without the decimal, but keeping in mind. Now, because I know it's going to be a very small number, I'm going to write that number on the right side. And you'll see in a minute why I did that. So now let's look at my exponent. My exponent tells me that I want to move 4 places, but it's a negative, so I'm going to move to the left. So this tells me 4 places, 4 place values, not 4 zeros, to the left. So keeping in mind where my decimal was, I'm going to count 4 places to the left. 1, 2, 3, 4, and this is where my new decimal goes. So 1.76 times 10 to the negative 4 in scientific notation is equal to 0.000176 back into standard notation. Now I put a leading 0 because it helps me remember that any number that starts with a 0 should have a negative exponent. Let's go ahead and try that again. So I already know that exponent tells me I'm going to move to the left. So I have to make sure that when I write my number, I write it on the right side. 6.128. Oh, I'm sorry. Don't write that decimal. 6.128. Now, keeping in mind of where my decimal was, I'm going to make sure that I am going to go 7 places left. Not 7 zeros, 7 places. Thinking of where my decimal was, I'm going to count 1, 2, 3, 4, 5, 6, and 7. And then here is where my new decimal goes. So this is going to be, I'm going to put a leading 0 just because I like it. And then I'm going to put so this is the new value in standard notation. I'm going to do one more example. So this is going to be so I have to think back, wait a minute, this doesn't have a decimal. So where is the decimal? Well, remember that 5 is a whole number. So 5 has a hidden decimal after it. So keeping in mind where my decimal should be, I'm going to count 3 places to the left. And how do I know that I'm going to the left? Because it's a negative. So keep in mind that my decimal was here. I'm going to count -1, -2, -3. Here is where my new decimal goes. So this is equal to 0. I'm putting a leading 0, 0, 0, 5. And I'm going to go ahead and write that note in there that when my exponent is negative, we count to the left. All right. And make sure you remember that your exponent tells you places, not 4 zeros. Okay? This is not 7 zeros. We're not counting zeros. We're not counting zeros. This was 3. This is not 3 zeros. Alright, you guys, that is our video for today. I hope that you were able to follow along with me. Remember, you can always pause the video wherever you need to. You can always re-watch the video as many times as you want so that you can pick up our objective.